Welcome back to EASD TV. Well, the rather neglected incretin, GIP, is everywhere this year, and I'm delighted to say that it's also the subject of the Minkowski Lecture, one of the very prestigious prize lectures put on at EASD. And with me, the award winner is Timo Müller, who's an institute director at the Helmholtz in Munich.
Thanks for having me.
We're delighted and congratulations. This is a distinguished honour to be giving the Minkowski Lecture. So you've been working on dual agonists for many years, and I said it was the neglected incretin, GIP. Tell us a bit more about that work and how you really got into it.
So I had the luxury to start working with these dual agonist molecules after I joined Matthias' lab at the Metabolic Disease Institute in Cincinnati. So I worked with these kind of drugs early on. And after we moved to Munich to found the Institute for Diabetes and Obesity in 2011, we continued this work, and my group was then focused on delineating how these molecules act in the brain and the periphery to regulate energy and glucose metabolism. And luckily, we could identify the brain GIP receptor as a key receptor that mediates food intake inhibition and decrease in body weight by GIP receptor agonism.
And at the time, was GIP thought to be interesting, but really not beyond interesting?
I mean, GIP was always interesting, but not for reasons that we know it today, right? So mice that lack the GIP receptor are protected from obesity, so you would naturally assume that you would rather antagonize the GIP receptor rather than stimulating the signaling. And we were quite surprised actually to see in our early studies that when you give GIP together with GLP-1, you get greater weight loss relative to GLP-1 alone. And now 10 years later, we know that GIP has its own effects in the brain to decrease body weight and food intake, and we have now identified the neuronal populations by which GIP acts in the brain and where it acts in the brain to decrease body weight and food intake. And
this is something that you've elaborated in much greater detail in your lecture, which is absolutely worth watching. I mean, it's fascinating what you say, because these interesting observations. I always remember doing a program for the BBC about leptin, and you'll remember those hugely fat mice, ob mice.
Yeah.
And everybody thought that leptin was this extraordinary wonder drug, and then it all just evaporated.
Yeah.
And with you, it's really been the opposite.
Yeah, I mean, leptin has a fantastic history, right? I mean, after Jeff Friedman discovered leptin, this basically brought leptin on the map that we recognize the adipose tissue as an endocrine organ, not just as a sink for energy, right? And leptin is a very powerful molecule. The problem is that obesity is typically associated with unresponsiveness to the hormone. And we did actually also some work early on in Cincinnati where we tried to improve leptin sensitivity, but this was not really successful. So it's really difficult to overcome leptin resistance.
And given all you know about GIP, and we are seeing, these astonishing kind of triple agonists and all those kind of things. I mean, we were saying a bit earlier that it's quite rare to develop and research something and then see it delivered in drugs.
Yeah.
So how does that make you feel?
Actually, as a biologist, right, seeing that your work translates into the clinic to finally help patients is the biggest reward you can get as a scientist, right? The clinicians have this every day because they are paid for helping patients, right? But as a biologist in basic research, it's very rare that you see your work translating into the clinic, and it's the greatest reward you can get as a scientist to see that what you're doing finally helps the patient.
Now, I can't help myself asking this, so apologies, but have we got to the end of the incretin story? Because there was a big paper recently that hinted that perhaps there might be yet another incretin.
Yeah. I don't think that the incretin story will die soon, right? I mean, we know that...
Well, that'll keep you out of trouble for a while yet, I suspect.
Yeah, I think I'm quite safe for my career. So, and even the incretins, right? I mean, we now know that it's not only activating the receptor, it's the way how we activate the receptor, right? So even so, different ligands activate only the GLP-1 receptor. Depending on the ligand, you can get totally different readouts from receptor activation. We call this biased agonism. And this is something that emerged over the last years. And
biased agonism.
Biased agonism.
You heard it here on EASD TV. Biased agonism. Write it down.
Yeah, and depending on the ligand, the activation of the GLP-1 receptor can have totally different effects, right? And beyond this, we also now know how we can modify the incretins to work better, to work longer, to have less side effects, and we can combine them with different molecules, as we have just seen with the polyagonists, and we have a triple agonist in phase 2, and I'm pretty sure that pharmaceutical industries like Novo Nordisk will soon come up with another molecule that uses incretin biology to further decrease body weight in obese patients.
So these drugs for diabetes and obesity are becoming like a kind of Swiss Army knife. You know, you started off with a single blade, and now you've got the kind of multi-blades, the thing that gets stones out of horses' hooves. You've got they're astonishing multi-purpose drugs.
It's absolutely right. Yeah, it's like the Rubik's Cube, right? Yeah.
So you're going to continue to work on this. You're going to continue to work on this biased agonism in particular. Yeah. Anything else that you think you can see coming up?
Yes, I think that we are now starting to learn how GIP acts in the brain, on which neurons GIP acts in the brain to decrease food intake and body weight. And the next question is, how do these neurons connect to certain areas in the brain, right? So the neurons that I'm talking about are located in the hindbrain. So the question is now, how does GIP activation of these hindbrain neurons project to other areas in the brain that are important for the regulation of body weight? For example, the hypothalamus, right? So this is now the next big question. And of course, it remains a big nut to crack, how it is possible that agonizing and antagonizing the same receptor can lead to a decrease in body weight, because this is a mystery that is still unsolved.
That is just bizarre, isn't it?
It is. But it's absolutely reproducible. Both sides are true. The question is, how is it possible?
Wow. Wow. So thank you so much, Timo Müller. Congratulations again.
Thanks for having me.
And if I can just say, if you are an early career researcher, what a fantastic field this is. There are so many unanswered questions, and they are so interesting. But there's going to be much more on EASD TV, so stay with us.